This week has left me pretty speechless. I found out that ChatGPT can look at raw EEG data from this Muse headband and make educated guesses from the raw data alone on whether I had my eyes open or eyes closed, relaxation measures, and even brain health biometrics like peak alpha, which have been associated with brain health, and even things like IQ scores. It really feels like a watershed moment for me this week because I feel like I'm finally understanding what AI is going to allow us to do at home with these neuroscience wearable devices. If you're new to this channel, I'm Dr. Cody Rall, a US Navy trained psychiatrist who specializes in wearable neurotechnologies. What I'm about to show you with ChatGPT and the Muse headband is extremely powerful. And the amazing part is there's nothing stopping you at home from trying this today. Okay, so for the first test, let's have ChatGPT analyze two basic EEG recordings. File number one is me sitting quietly with soft focus for 10 minutes with my eyes open. File number two is me sitting quietly with soft focus with 10 minutes with my eyes closed. And if you haven't seen this device before, this is the Muse headband. It's a $300 to $400 device that has peer-reviewed and validated EEG signals comparable to gold standard in some cases. It comes with a really nice neurofeedback meditation app, but there's a third-party app called Mind Monitor that you can get for $15 off the App Store to collect, store, and upload raw EEG data to get these pretty graphs here that I'll be loading into ChatGPT. I took special precautions actually not to label the graphs so that ChatGPT just couldn't look at the graph and have a reference on what I'm expecting it to put out. So here I'll do the prompt. I'll tell it I'm putting in two different EEG graphs. I've recorded one with my eyes open and eyes closed, and I'd like it to analyze the data and tell me which one's which. And then I load the graphs into ChatGPT for it to analyze. Analyzing. I mean, amazing. Without me even providing any education on what to look for in EEG signals, ChatGPT correctly states that the alpha waves should be more prominent when a person's eyes are closed compared to when they have their eyes open in the same state. This is a pretty well-known neuroscience phenomena called alpha blocking, and I thought it was so cool how ChatGPT just pulled that from the literature and could use it in a type of analysis. And I was surprised to find that it actually generated new images of the graphs with labels that it put there itself called EEG with eyes open and EEG with eyes closed. Oh, here you go, Dr. Cody. Here's your graphs back with the correct labeling from the raw EEG alone. And then it performed one of my favorite things about doing this with ChatGPT is that it gave its reasoning and logic. It explained it to me. And I love how it does that because it both confirms my knowledge of EEG patterns and how they should be analyzed, but then it also educates me on things that I might not have known before, as we'll see here shortly. Now for this analysis, the logic was pretty straightforward. It said that alpha was the blue line and that in the second graph, the blue line was consistently higher than in the first graph. So based on these observations, the second graph is likely the one that was recorded with my eyes closed, which was correct. Now, when I discovered that ChatGPT could do these types of analyses, I was just absolutely blown away. Like now I can massively speed up all my testing and analyzing processes for all types of experiments that I want to do at home. So I was sitting here thinking, if it can do this type of analysis, what else can these large data models do with my EEG and other brain recordings? So I asked a couple of friends that are in laboratories, but then I figured, why don't I just ask ChatGPT itself? So I went ahead and asked it, what other questions related to EEG and neuroscience should I be asking you about this data? There is so much here. What stands out to me is standard waveform analysis, comparing to population data sets, statistical significance, and longitudinal changes over time. But as you can see here, there's a whole lot more for me to do and investigate and document on this YouTube channel using ChatGPT with the EEG data. So next, I wanted to see what it would do with the more complicated graph. So I did a recording that started with my eyes open for 6 minutes, then eyes closed for 6 minutes, then actively meditating for the last 2 minutes of the recording. So I loaded that graph up and I started with more of an open-ended question just to see what it would do, asking it, what can you tell me about the attached graph? You can see here that it proceeded to educate me on what the different lines represented for brainwaves and what those frequencies tend to be associated with in the neuroscience world. I did notice the first big mistake that ChatGPT made, which was oddly getting the colors of alpha and beta mixed up. It said that alpha was green and beta was blue on the graph, despite the opposite being true. But it did get the other colors right, so I don't know why it would make such a seemingly careless mistake and error here. Maybe it was the way that the lines were spaced. I really don't know. So I went ahead and asked it where I was most relaxed in this recording. It proceeded to educate me that the greatest area of relaxation would be associated with high levels of alpha and theta. It initially gave me wrong results because of thinking that alpha was the green line. So I had to correct it and tell it the alpha was the blue line. It apologized and then it went forward with the analysis. So it took my suggestions into account and told me that alpha peaked around 9:15 a.m. on the recording. But even me just looking at the graph, I countered that ChatGPT, it looks like the blue line peaks at 9:17 a.m. Shouldn't that be the peak relaxation state? It is possible that it had dropped that alpha band data point altogether during pre-processing due to this error indicator in the gamma band at that same time point. And then it sort of backpedaled and said, oh no, you're right. Yeah, it looks like the peak was at 9:17 a.m. If that's the alpha, which is the blue line, that should be the peak relaxation value. So as you can see, this program is not yet perfect and it does make mistakes. I was pretty disappointed in its performance with this graph, but I feel like I'm making progress and seeing where its strengths and weaknesses are. And that's about where my investigation got a lot more interesting. Now there's a biomarker called peak alpha that companies like Muse and Sensei are taking pretty seriously as one of the markers for brain health that they want to include in their apps. Basically, within the alpha frequency band of 8 to 13 hertz, there will be a peak amplitude that represents that person's peak alpha. Research has shown that peak alpha tends to decline with age, poor sleep, stress, and other variables, and that you can actually increase it with practices like meditation and neurofeedback training. So I thought, wouldn't it be crazy if ChatGPT could just give me my peak alpha for these recordings? I thought there's no way that it can do peak alpha. I've had to send these recordings off to these companies and labs to get any sort of data back. And that would just be too crazy if ChatGPT could just calculate it on its own. So I figured I'll just ask it and see what it does. Dear ChatGPT4, can you analyze this raw EEG CSV file and tell me what the peak alpha frequency for this recording is? My mind is blown. All right, let's break this thing down. First, it told me all about what was in the file to include electrode locations, brainwave frequency columns. Then it said, let's perform a fast Fourier transform on these alpha wave data columns to analyze their frequency components. How does ChatGPT know how to do that? Then it ran into an error. I was like, I knew it. It's not going to be able to do it. It seems there was an issue with processing the data. I'll just adjust the approach to ensure the data is correctly formatted for the fast Fourier transform. Let's fix that and try it again. So it apparently fixed the error and ran the fast Fourier transform, which breaks the complex data into individual waveforms and draws the data from it. And then it proceeded to tell me that the peak alpha frequency for this recording was 8.97. It totally blew me away. I've run some other peak alpha calculations. They came out to 9.5 and 10.1. And in my discussions with Muse last summer, we found that these measures can vary day to day depending on how much sleep I've gotten, how much I've been meditating. So the variance in the data is not too surprising. And then ChatGPT actually taught me something that I didn't know before, which looking back, it makes sense, but there can actually be peak alpha values for each individual electrode site, and that to get the final number, those are often averaged together. I mean, at the end of the day, just having this capability at home totally changes how I'm going to do things on this channel. After a week of playing around with this, my head was just spinning. So I sent emails to a couple of different neuroscience friends that have laboratories of their own. Dr. Olson said that he thinks it's accurate about 50% of the time right now. Dr. Nico Regente out of UCLA said that he's been playing around with ChatGPT for the last few months to write Python code for analyzing neuroscience data, and that it was terrible at doing it at first, but more recently, he said, quote, "It's become quite proficient." Now, Nico did warn that EEG itself is really fickle by nature, and that it's important to know what's being done with the pre-processing of the EEG data, which is best done manually by a human these days, because any contamination in the data with muscle movements or dropped data points could actually really affect the final values. So Nico suggested that I ask ChatGPT about how it was doing the pre-processing. And ChatGPT was really honest with me. It said that it did minimal pre-processing of the data, and then it mainly just dropped some missing values and combined data from multiple channels to calculate things like the peak alpha, but no advanced processing or filtering was done to remove artifacts. It then proceeded to educate me more on pre-processing processes in the literature and gave me some suggestions of other software that I could use to improve my methods. So there's actually a lot here that ChatGPT could be getting wrong if the data is contaminated. So if you're playing around with this at home, it's going to be even more important to get clean data. So really try to limit moving around too much and get the best signal that you can, because any contamination of the data is going to affect the results. These discussions made me think about some of the errors that ChatGPT made, like mixing up the alpha beta colors in the lines, which is something that I could catch just communicating with ChatGPT, but it made me think about like what else is it getting wrong in the complexities of the data. I guess we'll just find out these things over time. And hopefully as I can plug in more advanced software like EEG Lab and other programs to filter and improve the data, ChatGPT or whatever AI engine I decide to use with my AI companion will get more and more accurate over time. I mean, overall, I was just completely blown away that it even tried to analyze the data, let alone determine eyes open versus eyes closed, identify when I was meditating, and calculate peak alpha values. As Olav Krugolson and Nico Regente told me, ChatGPT is not ready for prime time neuroscience studies yet, but certainly is flexible and powerful enough to start playing around at home with these wearable EEG devices. You can just feed it the data and see what it says. And I felt like I just learned so much from loading up the data and asking ChatGPT about it, because I just loved how it described the logic and explained what it was doing with the data and taught me things that I didn't even know, like calculating peak alpha values from individual electrodes. And I definitely pushed it to the brink a couple of times by asking it to do certain things with the raw EEG data. It simply would say an error was made and that it couldn't progress any further, but then it suggested additional EEG software to use to fill in the gaps of what it cannot do at this point. So my plan is just to start testing different AI engines like Google AI, Microsoft Azure, or TensorFlow to see which ones work best for these different neuroscience data sets. And then I plan on linking the best neuroscience software and AI engines together to create a mind-reading AI companion through an AI integration service like Eden AI and document it all here on Techforpsych. So be sure to subscribe to see how I'm building this over the next few months. I really hope you enjoyed this video and you are as excited as I am to start using these extremely powerful tools to explore our own minds through these wearable neuroscience devices. If you want a video that talks more about EEG basics, check out this video here. I'll have another video next week where I'm going to analyze a full month's worth of Muse data and also have ChatGPT take a look at MindLift quantitative EEG reports. So there's a lot coming. Hope you enjoyed it, and I'll see you then.